Hello, my name is Carl, and today I'm going to be discussing single recessive epistasis. Epistasis is a type of gene interaction where one gene masks the effects of another. It helps if we imagine a linear fictional biochemical pathway. In this example, we are going to imagine a fictional pathway for dog fur coloration. We're going to start at an initial colorless precursor, where enzyme A is required to reach the green intermediate phenotype, where enzyme A is encoded by gene A, where at least one dominant allele is needed. We will end with a purple final phenotype, where gene B produces enzyme B, and we will need at least one dominant allele to produce gene B to get from the green phenotype to the purple final one. If we have a dominant allele for gene A, but not for gene B, we stop at the green intermediate phenotype. If we have a dominant allele for gene A and gene B, we get the purple final phenotype, and if we do not have a dominant allele for gene A, we never progress past the initial colorless phenotype. Let's do an example. We will cross two parents who are heterozygous for both traits, and we will get the following genotype ratios out of 16. 9 of these offspring will produce a dominant allele for both gene A and gene B, and they will produce the purple final phenotype. 3 will produce a dominant allele for gene A, but not gene B, and stop at the green intermediate phenotype. And 4 will not produce a dominant allele at gene A and never progress past the initial colorless phenotype, and the genotype for gene B does not matter. Let's do one more example. In this example, we will cross two parents where one is heterozygous for one trait and one is heterozygous for the other, and then they are homozygous recessive for opposite genes. Out of 16, we produce the following genotype ratio. 4 will produce a dominant allele for both gene A and gene B and produce the purple final phenotype. 4 will produce a dominant allele for gene A, but not for gene B, and stop at the green intermediate phenotype. And 8 will not produce a dominant allele for gene A and will remain at the colorless initial phenotype. As you can see, the ability for gene A to produce the green intermediate for gene B to act on is what defines this type of interaction as single recessive. Hopefully now you understand single recessive epistasis. Thank you.